Hi, geometry students. This is lesson 2 of unit 14. Check your homework answers for the lesson 1. Okay, today we're just focusing on one new thing, and it's when you have intersecting chord segments in a circle. So if you have two chords that intersect inside a circle, the product of the measures of the segments of one chord equals the product of the measures of the segments of the other chord. So this sounds really confusing, but it actually isn't bad at all. So here are my chords, C, D, and A, B, and they intersect at E. If I construct triangles, I want you to notice that the angle at C and the angle at B are congruent. Do you see why? They both intersect this arc, therefore making them congruent. The angle at A and the angle at D are also congruent because they both intersect this arc. Obviously, angle E is congruent to angle E because they are vertical angles, so they're congruent. So by angle-angle similarity, I have similar triangles. So I can set up a proportion. So this is going back to one of our previous units. I know that AE is to, now what's going to correspond to AE? It's going to be ED as CE is to EB. So when I take the cross product, or the product of the means equal the product of the extremes, I get AE times EB equals CE times ED. And this is what we're going to be using in our problems. So what you're going to do is you're going to say, this segment I'm coloring in green, AE, times EB, the other segment in green, is going to equal CE, purple, times ED, the other purple. Let's give it a try. So number 1, I have two chords intersect. So all I have to do is say 8 times X equals 4 times 6. I don't have to worry about setting up the similar triangles. I can go ahead and prove it to someone, but I know that's how it's going to end up. So I have 8x equals 24, divide by 8, x is 3. Our next example, we have BE is 4 to uncover. So we have CE is 16, DE is 3, BE is 4, find AE. So same idea going on here, 16 times 3 is going to equal x times 4. So 48 equals 4x, divide by 4, x is 12. I can make these a little more fun, a little more interesting. So I have ZQ is x plus 3. YQ is x minus 6, WQ is x, and XQ is x minus 5. So I have two chords that are intersecting at Q, so I'm going ahead and say x times x minus 5 equals x plus 3 times x minus 6. So x squared minus 5x. Oh, come on, pen, you're working so well. There we go. Notice on the right here, I'm going to have to FOIL or double distribute. So I get x squared, and then this gives me 3x. And up here, I get negative 6x. So that's negative 3x minus 18. So at first, I think I have a quadratic that I might have to factor, but notice if I take away x squared from both sides, My x squareds are gone. I have negative 5x equals negative 3x minus 18. So now I'm just going to add 3x to both sides and get negative 2x equals negative 18. Divide by negative 2, x is 9. Notice it wants me to find the length of each chord. So remember, a chord is all the way across the circle. So I'm doing those in yellow right now. So that means I have to sub in. So wx, and I have to figure out zy. So I'm going to plug in 9 every time I see an x and figure out what those totals are. So wx is 13 and zy is 15. All right, so that's the new material, but the stuff we learned previous lesson, I think we need some more practice on. So we're gonna do a little more of that. So we have in circle O, radius AO is perpendicular to radius OB. If OA is 4, find the length of chord AB. So you have to actually draw the picture yourself. So I have circle O. So that means the center is O. And radius AO is perpendicular to radius OB. So they're both radii. And OA is 4. They want me to find the length of chord AB. Well, since they're perpendicular, this is a right angle. And since they're both radii, this is a 4 as well. So this is just Pythagorean theorem. So 4 squared plus 4 squared equals c squared. So 16 plus 16 is 32 equals c squared. Take the square root and simplify radical 32. So that would be 2 squared times 2 squared times 2 in the radical. So out of my radical, I can pull out 2 2's. So that's 4 radical 2 for my length of AB. Next for 5, I have chord AB is 5 units from the center of a circle whose radius is 13. Find AB. All right, so I've got the circle. Got a center. Didn't give me a name, but that's okay. I know I have a center. Chord AB is 5 units from the center. So that means, so here's chord AB, that the distance I'm talking about is perpendicular, right? That's our definition we've been using all year about distance. If you're some distance from something, that means you're perpendicular, not at a slant. And then they tell us that the radius is 13. So that means that I can make a radii to B. So let's say I call a circle O. So OB is 13. And now they want me to find AB. Well, you might remember our theorem that says if I have a chord that's a certain distance away, and that distance obviously is perpendicular, then it divides the chord in half. So whatever I have for this right triangle is going to be the same distance. So I can use Pythagorean theorem, or maybe I just know what this is. But I have my leg squared plus my unknown leg squared equals 13 squared. So 25 plus b squared equals 169. Subtract 25. B squared equals 144. So B is, come on pen, 12. That's not my answer though, because 12 is only half of it. I have to double. Remember, B is also the same as X, so I have to say 24 for AB. Okay, next, number 6. I have circle O, and I'm told that OP and BD are perpendicular. Remember, that symbol means perpendicular. Find the radius of the circle if OP is 7 and DB is 20. All right, what do you remember about DB if it's perpendicular? It has a certain distance from the center. Then it is cut in half. So each of these are 10. So that means if I draw in this radius from O to B, I can use Pythagorean theorem to figure out the radius. So 10 squared plus 7 squared. My 7 is on that leg. It looks like right now it's the hypotenuse, but I wrote it in for OP. Squared equals C squared. So 100 plus 49 is 149 equals C squared. And I take the square root, and that's just the square root of 149. And there's my radius. Next, I've got radii PR and PS are perpendicular. If RS is 6, find PR. All right, so I've got a circle. They're telling me I have 2 radii. Notice the radii share the letter P, the point P. That means P must be the center. So they are perpendicular. So here's PR. Here is PS, and they're perpendicular. If RS is 6, can I find PR? Let's call PR X. What do you know about PS? Remember, it's a radii, so it's also X. So I can use 2 ideas here. Some of you might recall my 45, 45, 90 triangles, and you can do that relationship. Remember, we had across from the 90, and then we had our across from the 45s. I just drew it over on the left here. My pen was acting up, so I just drew it quickly for you. So if you want to do it this way, you would say, okay, so 6 equals D radical 2, divide by radical 2, because I have that isosceles right triangle. So D equals, and now I have to rationalize this. So I'm going to multiply by radical 2 over radical 2. So that's 6 radical 2 over 2, which is 3 radical 2 for X. Or you can use Pythagorean theorem. So with Pythagorean theorem, you would just say x squared plus x squared equals 6 squared. 2x squared equals 36. Divide by 2. X squared equals 18. Take the square root. X is 3 radical 2. So lots of ways to do this, but I just want to pull your attention to that 45, 45, 90 triangle, just because that'll be really helpful next year if you can start to recognize those relationships. All right, 8. We've got circle O, so that means it's the center. We have EO and AB are perpendicular, as are OF and CD. And we have EO is congruent to OF. If AE is 2x minus 7 and CD is 10, we want to figure out the value of X. Well, what do you remember? In this situation, if the chords are the same distance away from the center, and I know this because they're perpendicular and I have the congruency marks, then they must be the same. I also know that AE is congruent to EB. So if I double 2x minus 7, it should equal 10. So I'm putting together 2 different theorems that we learned in the previous lesson. So I have 4x minus 14. Or maybe you decide to divide by 2 first. Either way is fine. Add 14. So 4x equals 24. Divide by 4. X is 6. And our last one, the chord a chord of length of 10 is drawn 12 units from the center of the circle. Find the diameter of the circle. So draw your circle. The chord is a length of 10 and it's 12 units from the circle. All right, so here's my chord. It's 10 and it's 12 away. Remember, anytime you talk about distance, it's got to be perpendicular. So this is 12. And because I know this is perpendicular, since it's a distance away, this is being divided in half. So I know the whole thing's 10, but that means each piece is 5. So now they want the diameter of the circle. Well, I can make a right triangle right here. And remember, this 12 is really over here. Get rid of that. There we go. So I just have to figure out the hypotenuse here and then double it. So I'm going to do 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. 169 equals c squared. Take the square root. C is 13. So that's the radius. I have to double it to say my diameter is 26. All right, that is it for lesson 2, which hopefully was a nice little review of some of the things we did in lesson 1. If you have any questions, please see me on Google Meet, and take care, everyone. Bye.